Hello, today we are going to talk about Cambridge IGCSE Physics 0625. First lesson, motion, forces and energy. 1.2, motion, core, part 1. And we'll see core part in the syllabus. First one, define speed as distance traveled per unit time. Recall and use the equation V is equal S over T, where V is the speed, S is the distance, T is the time. Second one, define velocity as speed in a given direction. Third one, recall and use the equation average speed is equal total distance traveled divided by total time taken. Fourth one, sketch, plot and interpret distance, time and speed time graphs. Fifth one, determine qualitatively from given data or the shape of a distance time graph or speed time graph when an object is A, at rest, B, moving with constant speed, C, accelerating, D, decelerating. Sixth one, calculate speed from the gradient of a straight line section of a distance time graph. Seventh one, calculate the area under speed time graph. Two, determine the distance traveled for motion with constant speed or constant acceleration. 8.1, state that the acceleration of free fall g4 an object near to the surface of the earth is approximately constant and is approximately 9.8 meters per second per second. So here highlighted area is we are going to talk about. The motion. Speed is defined as the distance traveled per unit time. If the speed of something is changing, it is accelerating. The acceleration of free fall near to the earth is constant, which is 9.8 meters per second per second. Average speed is equal total distance divided by total time. Distance is measured in millimeters, centimeters or meters or kilometers and time measured in milliseconds, seconds, minutes or hours. Remember to convert units to make sure everything is equivalent. For example, if distance is in kilometers and time is in hours, then calculate distance of over 1000 and time into 60 to get everything in meters and seconds. Velocity is the speed in a given direction. Acceleration is the rate of change of velocity. So acceleration equal change in velocity divided by time is equal v minus u divided by t, where v is final velocity, u is initial velocity, t is time. In a distance time graph, when we take the distance time graph, we can see this green line shows a fast steady speed moving from 0 to 100 meters in 5 seconds. The blue line when we get shows a journey with the stop and return to the starting position. So when we see the red line shows a journey starting 2 seconds later. Then the other two with an initial acceleration, then a deceleration and then a stop. So we'll see the gradient is straight. The negative gradient is returning back to the starting point. The horizontal line means it is stationary. If the distance is 0, it is back at the starting point. A curved line means that the speed is changing and it is accelerating or decelerating. Distant time graphs when we get further. So we can see this is horizontal line, speed is 0. It's kind of slope line. This speed is constant and positive. Downward slope line with the speed constant and negative. We take the curve line upward, the speed is increasing. We call it as accelerating. We get the slope. This curve line, this kind of gradient, it is the speed is decreasing. We call it as deceleration. So in a speed time graph, when you take this is the speed time representation, this green color line shows constant acceleration, this red color curve shows change in acceleration, And this blue color, first part, it is constant acceleration, then mid part is constant speed, after that constant deceleration. So the gradient is acceleration, negative gradient is deceleration, horizontal line means constant speed. If the speed is zero, it is at the rest. Curved line means that the acceleration is changing. The area under the graph is the distance traveled. So when we come to the speed time graphs, so the horizontal line shows zero acceleration, positive gradient, slanted line shows constant and positive acceleration, downward line shows constant but negative acceleration. The upward is kind of curve showing acceleration is not constant but increasing. This again curve showing acceleration is not constant but decreasing. Obviously, this question, A part, a bus travels at a constant speed, it stops for a short time and then travels at a higher constant speed. Use the axis in figure 1.1, draw a distance time graph for this bus journey. So bus travels at constant speed, so we can draw like this a constant speed. So slope is lesser, can tell it as gradient lesser and lesser constant speed. When it stops, it is like this way. It's not moving. Time is going, but distance same. So finally, what has happened? Then travels at a higher constant speed, mean again constant speed, but higher mean slope is higher, gradient it mean higher constant speed. We are comparing the first slope with the final slope. That is how we are getting higher slope for the final one, and the first slope it is lesser than the final one. B part, a lift, we call elevator, starts from rest at the ground floor of a building. Figure 1.2 is the speed time graph for the motion of the lift to the top floor of the building. Use the graph to determine the distance from ground to the top floor of the building. Here we know distance travel is area under the graph. So when we get the measurements of this graph, you can see the top horizontal part is 12.5 seconds. Bottom part it is 25 seconds. You get the height, it is 3.3 meters per second. So we can see this is a trapezium. So trapezium area is when we get, so upper part it is A, it is base again, B, it is also base, then height. We are getting this perpendicular height. So we can write the area half into base plus base into height. So area is equal half into A plus B into height. So area it is again half into, we can see A, it is 12.5 seconds plus B, it is 25 seconds into height, it is 3.3 meters per second. So we can get the sum of 12.5 plus 25, which is 37.5 seconds. So half into 37.5 seconds into 3.3. So we will get half into 123.75 meters. So area is 61.875 meters, which is around 62 meters. So answer is 62 meters. So when we come to the free falling objects, so free fall is when there is no air resistance. So we can see the weight is the only force acting on the object. So when we come to the Newton's second law of physical method, so here only force is W, that means weight. So which is m into g, mass into gravitational acceleration. So we can subject A like this way. So F divided by m, that means W divided by m. W we know mg. So m to m we can cut off, then A is equal g. That means one and only acceleration downward is g, that is gravitational acceleration. So mass of the object does not affect the motion. Shape of the object does not affect the motion. All objects fall at the same rate in a vacuum. So that is the free fall in objects.